Hello and welcome to yet another edition of our growing community. This one is all about MCP, like as you've probably seen, right? So we've got a pretty good lineup, if you don't mind me saying this. We'll have Mihaela talking about MCP versus REST APIs. How does it make sense to expose this data to external systems? Then you'll have myself talking about, okay, do we really need MCP, or are tools enough to create rich agents? Andrei talking about how to actually create an MCP server in with the latest features in .NET 10. And last but not least, Daniel talking about MCP plus Microsoft Agent Framework. Before we start, I just want to say, I know right now in Romania, there are some pretty big, let's say, civic actions taking part. And if you want to take part in one, don't worry, this talk will be recorded. So there's still time to join the other fellow friends in the markets. Right. That being said, I'd like to introduce our first speaker, which is Mihaela. Hello, Mihaela. And of course, I need to hit the button and you will appear. Awesome.
Yeah, I'm here.
Hello.
Not being more technical tonight than an activist, but oh well. Sometimes you have to choose.
Yes, sometimes, yes, not, but we'll see. We'll see. There's also one Friday, but doesn't matter.
It's okay.
It's okay.
Yeah.
How are you? Glad to have you here, by the way. Thanks for accepting our call.
Thank you for having me. Actually, it's it's the pre-Christmas kind of session. Like I had very much fun doing this, and yeah, the result of this demo and presentation, whatever, it's actually me just being random, trying stuff, trying new things. So yeah, I hope that is going to be visible and actually is going to bring value.
To be honest, one thing I was reading about is that lately, like in the past decade, like everything has become way too polished, and it's like the joy of finding out things just isn't there. We need to produce, we need to market ourselves. It's crazy. So yes, I would +1. Just learning interesting stuff. But I will slowly but abruptly fade away and let you get into that.
Okay, thank you. Let me share my screen again just to see that it's working. You should see a slide. Let's see if it appears. Seems like it appeared. So we're good on that. Looks good. Oh, I can see myself. That's nice. Cool. So again, nice to be here tonight. Even if it's online, still it's good because we get to reach out more people and not just our local community, which is also very, very nice to meet from time to time. But yeah, it's just another kind of experience. Let's put it like this. My name is Mihaela Ghidersa. I'm a technical lead at Ignat Health. When I'm not, doing stuff at my job, although they are highly combined with what I'm doing outside my job. Also, as I was saying, if I find something interesting, if I don't know, I experiment with something, find that it's something worth sharing, or maybe something that I like to get more opinions on, I'm just, either writing some, I don't know, article or some post or something, and then see how that is working, or preparing a session, with my findings as we are doing today. So yeah, let's just learn stuff, or at least do some exchange of information. Disclaimer, I don't know if anyone is today, but I feel like saying this. I'm not an MCP expert. Yeah, I'm experimenting. I'm going with the flow of tech that, you know, everyone is going with. So I've been playing with this. I had, you know, in my, I think it's been a while actually, since there's been such a wave of excitement for me to actually experiment with stuff. And as Vlad was also saying, like not doing polished stuff and just like trying stuff and working with whatever appears and then, you know, writing some more or, you know, just arguing with some sort of AI and, you know, usual developer kind of activity. And the second thing that I wanted to say, if you're Python expert, right? Because my demo today is going to be in written in Python. I'm also in the process of learning that and experimenting, but I like to, well, like, you know, when I start doing something challenging, why not do it more challenging and doing with something that you are not, you know, an expert on. So if you are an expert, please think about the fact that we are in this wonderful period. Christmas is coming. So yeah, just be a good person and try to look at what I'm trying to say. If you find any issues, maybe I'm just very good at hiding or at least at doing new things, but we'll see. You are going to tell me afterwards. But yeah, I've been, you know, this whole presentation started as trying to see exactly how we can actually use MCP or concepts from MCP while still, you know, like not having this whole new, okay, I'm leaving everything and I'm just going to work with AI and I'm going to introduce agents and MCP and everything that I've been doing until now is just going to trash because now I'm this enhanced engineer that I have to keep up with market and so on. So I was thinking about like our APIs and the backends that we've been working with for so long. And for so long, APIs were a contract between, you know, people, between developers or between yourself and in the past and yourself in the future doing the front end maybe. So maybe one team built them, another team learned how to integrate them and how to actually, you know, improve them in the process. And what I see that is different today is not the technology stack, right? Because we didn't outgrow HTTP, REST, whatever. What changed is the consumer. And today in this conversation, in this demo, you're going to see that I'm having a very boring backend that is called in 3 different ways. You know, once by a simple script, then one that is smarter, and then by an AI model, just to see a bit the transition, but nothing about the backend changes. So it's about the integration story that actually changes. And that's because the assumptions behind our APIs were, you know, we are going to always have humans. We assumed someone would understand our intent from documentation, understand exactly what is the kind of usage that we are looking for, and also, you know, recover or give feedback when something went wrong, and then we are just going to, you know, discuss and have those refinements and so on, and get with something in the end. Well, when it comes to AI, we don't really do that. AI doesn't learn by, you know, doing, or not in the same way that we are doing, you know, reading, experimenting and stuff like this. It makes decisions based on structure, based on constraints, semantics. So if meaning isn't clearly encoded in the, you know, in the interface itself, the model has nothing solid to reason about. So that's exactly the shift that maybe I'm proposing today. We are not discussing about new endpoints, new protocols, but a different way of exposing some capabilities that maybe non-human. I don't even know if that's valid to say, but something else than then people, then developers, and humans can actually use them and create something that is reliable. And the interesting part that I saw is that, with MCP, we don't have this pretend that it understands the system. We are going from the, if I'm talking about a colleague, I'm thinking, okay, but he already knows the context, right? We are in the same team, or maybe we are working on the same, we did some refinement at some point. So that other person or entity, it knows exactly what we are supposed to do. When it comes to AI, it's a bit different, zero knowledge. We go from zero, right? That's why we have to be very precise in our prompts and in our explanations, and have patience and learn how to prompt and become experts on prompting and so on. So in my demo, the client doesn't know what a user is, how, for example, inactivity of a user is calculated, how emails are being sent. All it sees is a list of available actions, tools, with names, some descriptions, and from that it starts reasoning, trying to do something and actually have some actions. And this is the shift that we are actually underlying, going from documentation driven to discovery driven, actually, like discovering what exactly is the intent. And yeah, we're using usually, right, we are using endpoints. They are being exposed using URL, verbs, payloads. We were discussing about AI that it doesn't work like that, right? It's not the same kind of approach. So we are actually, we need to start thinking in more like actions and not like some clear capabilities that we have in our system. And once you think in capabilities, orchestrating everything that you have in the backend naturally moves outside of the backend and into the client. So the backend remains something simple, stable, that's that, and then you can experiment in the client. By the way, if you have maybe, I don't know, production examples, I'm interested to discuss more about this. Because as I said, my backend is intentionally boring, plain Python functions, no AI, no orchestration logic, no prompts, nothing. I didn't change it in order to accommodate the MCP. What I started was putting an MCP server on top of that, a layer that exposes those backend functions as tools, right? So the backend doesn't become smart. And this is actually, this structuring is what is making it maintainable, at least at this level that I'm looking at today. So let me walk you a bit step by step through the demo, because I keep talking about my let's see. Okay, so basically first we are having this backend, very simple backend, just getting some users, last activity, inactive users, send emails. So just some functions that we are working with. Then we are discussing about the server that basically is, built using fast MCP, which you can think of like fast API for MCP. And basically lets me take an existing function and mark it as a tool using exactly this this attribute, right? MCP tool. And same MCP server, same tools, same backend, always the same. What is actually changing is the client. So I prepared some clients in here to play with. Let me minimize a bit this thing. So in here, I'm not doing anything special except for what I already mentioned. So it's just a layer that is actually preparing those functions to be considered as tools. So first I have this silly client. Where is it? Silly client, where I'm just testing to see exactly if my tools are being called. So I'm not doing anything in particular. Yeah, it's just calling this. It's boring, no kind of, I don't know, orchestration being done on it. Well, I'm just calling stuff, right? I could as well do the same from a normal client, and that's that. I don't need MCP. But then we can go a step further and actually introduce a smarter client, like the next step into this process. I was like, okay, let's see how it can bring value, or until what point it can bring value if I'm not actually using an AI in between. So let's go with this one. Client. And let's see what is happening in here. In here, I can see that already I have some sort of logic being done. And also I've added some, depending on that logic that I worked with, and I'll show you in a minute, I'm also giving it some, some prompt kind of, or suggestions for the user in order to retrieve the kind of information that I have in this. Yeah, so basically I'm just doing some basic orchestration management by having some predefined keywords, in order to actually decide what kind of calls I want to do behind it, what is happening behind scenes. So nothing special, nothing out of this world, just the next level of logic. And of course, I'm going to be a very good girl, and I'll do whatever it says. And yes, it's giving me exactly what I was expecting to give, because there is no magic, no smart thing in between. It's just some logic that I already implemented and added as a capability to the user. Okay, and then I'm going in here. I have, by the way, I have 1, 2, 3 smart. So it's a lot of smart in this, but also it's because I've been doing some changes right before the demo, because why not? I was trying some stuff that I saw it's not really working. So ignore this. Okay, and then we're going with the simple one, right? Where we already are doing some, adding some prompting, adding some logic, actually instructing the AI. By the way, this is using let me show you again. One sec. Yeah, so basically I'm building all the rules for what I wanted to do. Also educating it in the prompt about the actions, which are the tools, in order for me to actually create all the logic that I want in the back. And I'm integrating with this is the model that I'm using, is ChatGPT 4.1 mini. So let's see how this one works. As I said, did some changes. Okay, let's go with the smart LLM client. Okay, and let's use the same that I used before, just to showcase. Okay, so basically we are asking the LLM for a plan for this. He's looking at what we're having, what I'm having here, send reminders to inactive users, and it's like, this is the tool, from the list of tools that we are having. This is the tool to be used. I'm not specifying any, what inactivity it means. So it's just taking a default, which is something that I gave it in the beginning, minimum of 10 days. And then it's doing what I'm asking it to do. Now, the difference between this one and the previous one is what happens inside the client. Because this time the client sends the user a request with the available, the available list of tools in order to go further to the language model. And the model itself is not executing anything. It simply produces an execution plan, right? That's why I also use this created this logging in order to see exactly what is happening behind. So in this setup, the LLM is only a planner, and it takes, as I've showed already, a prompt, right, that we are using, the usual prompt that we are doing, combines it with a description of the available tools that we are having. I want a smart one, yes. It should, okay, in here. So I also want to show exactly what where exactly we are doing this, and then it's returning a plan with what to do, what are the tools, and in what order to work with them, and so on. So basically, the LLM never talks to the backend directly. It decides what should happen, while the MCP itself enforces what is allowed to happen. So it's giving exactly what it can be accessed in what way, but then we are just working on that plan that I was mentioning before. And since we are discussing about that plan, I would like to actually show something that I've been playing with. That's how these three versions appeared. So I've been playing with this, and then I was looking, okay, it works with this simple one, but if I'm going and actually putting, to send reminders to users that are inactive for at least 10 days. So basically, in here, it needs to work with two tools, right? We are having, the plan needs 2 rounds of execution, if I can put it like this. So first, we need to identify what are the inactive users, and then, send the reminders. And as I was looking at this, I've noticed that let's do it like this, because when it wasn't working and you fixed it, and then it's working and you can't show what you have to. Let's try it again. So I'm doing this, send reminders, notify, but it already has context. So a thing that I noticed is that it wasn't really keeping the context really well. And in order to see a bit better how things are happening behind, that's how I ended up going with this third client that I'm using, where I'm actually trying to keep track of the the planning rounds that I am having and working with, basically. So let me show you how it works. Okay. Oh, it's in here. Okay, so let's go with the third one. Okay. Oh, I'll have to do something. Just a sec. Let's just play in here. I don't want to show you for now my API key, which I think I showed you already in the beginning. But you didn't notice it, so I hope. Anyways. Okay. So right now, if we are going again with this one, let me take it in. And then we can see exactly, I just added the maximum of rounds that we are working with, but we can see, okay, in first round, what is it doing, and then what is happening in the second round of planning, right? Because it's actually using the context from the previous round. So I'm working with data basically in the same planning. We are working in several rounds because we are using data from the previous one. So I wanted also to show you another a more complex one with more rounds. For example, if we go with this, let's say that I want to send reminders to inactive users with a certain message. So basically it's send reminder inactive users, but also this message. So let's see how is this unfolding. So basically we are first, it's action, okay, I need the list of inactive users, blah, 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 get a list of inactive users with at least 10 days of inactivity. We are having the list and then notify inactive user, right? And we are having two, it's Alex and Sam that are inactive, right? So then we are ending with this. But let's see also what is happening when I'm giving it something that I don't have, right? Like delete, I don't have anything defined for delete. So let's see how, if it's actually doing, if it's, I don't know, making decisions for its own or what is happening. Yeah, so it's not exactly doing what I wanted it to do, but it might be because of the latest changes that I did. Bear with me. Let's go to this one that it should be more stable. Yeah, normally it shouldn't go to another another round and trying to, or just deciding to take one of the, but yeah, it seems like right now it doesn't really work as expected. But please, trust me, I think I messed something in the way I'm calling, in the logic that I added for this. But trust me, if you're doing the logic as it should not do anything that you don't want it. So one lesson, if I may call it like this, from this is test it very well and don't do changes before releasing to production or doing a demo. But yeah, as I was saying, this is the fun of it, and that's why it's interesting, because I can experiment and actually not have big stakes. Okay, so basically, of course, if it is about implementation details and stuff, I can share it with you later and we can discuss more. But I just want to draw some conclusions, because I think I went a bit long with my demo. But long story short, the LLM, it doesn't touch the backend. It never calls the API directly. Doesn't have any credential. All it does is suggest those plans that I was showing you. First do this, then do the other thing, then the next phase, and so on. The execution itself is going through the MCP. It says exactly, the MCP, it says exactly what is allowed to do, and then the backend just goes and does what was intended already. So the LLM decides, the MCP enforces it and validates, control what is happening in there, and then the backend executes what it has to execute. Then if, as I was telling you in the beginning, I started playing with this and doing this actually out of experimenting and trying to not take things that seriously, and trying to put things like integrate these new information and tools and so on, how to see how it can be integrated in what we are already having, and not like throwing everything. But maybe something that it's worth mentioning, or what I've noticed, is that while experimenting with this and playing, there are some things that I started thinking differently about, which is, okay, from the traditional kind of thinking about APIs, like what kind of actions should I use? Are they safe to actually be called, one by one in the way that I'm defining them? And an example, a very good example, was this delete one. Yeah, I have to be very careful about, or how I'm actually creating the logic in order to not confuse the model. Are they clear enough for the model to understand? And also not only the action itself, but also the prompt that I'm creating for that, or in order to integrate it. Can they be composed? And you've seen exactly a bit on how two actions can be called in the same plan and actually use the data from one to another. So of course this doesn't make justice for a true production system where you can actually go and experiment with a lot more and actually have something very stable or maybe very clear. But it's a good starting point to see exactly if this is something that that fits your case. And maybe also to keep in mind that MCP doesn't replace APIs; it makes them usable or reusable for a new kind of customer or user. Maybe in here, just roughly, think in capabilities, and not in the resources that we've been thinking before. When it comes to, again, integrating this kind of functionality, try small. Try to do things as small and composable, and don't, I don't know, for example, if you have something very complex, it might fail. If you're trying things very complex, like try to build it step by step. Be careful how you're calling your tools. We already discussed about thinking in actions. Not going to repeat on that. Think for the model, of course, and also maybe the most important part that I didn't mention is to make sure that you are able to debug, right? To have all the tools and all the, I don't know, call logs and I don't know, some IDs per request, metrics for your tools in order to see exactly where it can be the problem. I've been doing just some basic logging in the terminal, but keep in mind that in order to understand what is happening in there and actually take some actions while, I don't know, issues appear, or you just want to see exactly how your system evolves, try to also plan from the beginning on this. So don't, especially if you're experimenting or if there are high stakes. Then I've been thinking, I'm assuming, but I also ask myself, okay, but maybe there are still some things that are going round around in my mind, and one of them is if this is just a fancy wrapper around some APIs, like, okay, we have now AI and stuff, and we are just trying to make things more complicated or more fancy, just to say how everyone is creating AI systems right now. We are, if it's this kind of situation. And the idea, at least for this case, in this case, is to showcase that we are not replacing the APIs, but that you can build this wrapper that changes who the API is optimized for. And of course, if you don't have AI agents, MCP doesn't bring value. Like adding this, if you're not thinking about evolving your system in this direction, it doesn't bring value. Of course, it's not something that you should do just because it sounds, I don't know, that someone talks about in a presentation. But if you do, if you need it, it removes, from my perspective, at least from the conclusions that I have at this point, is that it removes a lot of, brittle orchestration that usually is being done, and a lot of code that otherwise would be written. Then another question: why not just let the LLM call APIs directly? Because you want to keep it safe, you want to keep your boundaries, right? And as you've seen in my demo, we didn't touch the backend. We didn't have credential. It doesn't know endpoints. The execution goes through the MCP, where we can, of course, extend, validate, restrict, log, do all sorts of stuff. So you don't want to let a model call your APIs directly, because you need to have some control in there. Then what happens when the model gets it wrong? It doesn't happen anything. If you're doing it right, it should, I don't know, maybe have some fallback where you say, okay, this is not something that we are able to do. Just go over it, Then isn't this just moving complexity somewhere else? It depends on how complex your system is, right? Because if you are adding complexity in order to accommodate this, then yes, it is. But if you are having a heavy, a very complex orchestration logic that, I don't know, is being built between your services, or maybe some workflows that you are forced to use, across clients, or a lot of integration code that is not very helpful and is bringing issues when it comes to investigating maybe some flows or seeing what is happening at some point in your system, that maybe it's good to have this kind of layer that centralizes, decision making, execution control, of course, as we were discussing, and the system becomes easier to reason about, not harder to work with. At least, again, from the conclusions that I've been able to take away until now. And the last question that I thought of, we'll see if there are any questions maybe later. What's the real developer takeaway here? I think that it's exactly this smooth transition. I don't know about you, but I've been, or at least when I'm opening LinkedIn, I am seeing like how not important being a developer is going to be soon. And now it's funny, but it wasn't always funny. And what's interesting or reassuring is that you still have to design business logic, even if you're using AI tools, integrating some AI tools in there. You still have to enforce some rules. You have to know how to protect your data. You have to know how to make sure that there are no side effects to what you're doing and that your system is going smoothly. Because as you've seen, I told my system to delete something and it gave me the list of users, even if before it was working. So still there is a need for attention and person in there. So this is not about replacing APIs, the backend work, let's say, if we can discuss more, as an overview, but is about making backend systems usable by a new kind of client, breaking that barrier and actually working with AI without, going crazy with working with AI. And just as a recap, if it is to remain with something, identify tasks, not strict endpoints, so that mindset switch that I was mentioning. Wrap the REST calls behind tool functions, make tool names and schemas semantically obvious, so make sure that you are using the right kind of naming, and also think about not making it very broad, but more like specific enough. We discussed about moving that orchestration code and logic. Add, of course, all sorts of guardrails in that layer that we've been discussing that we are adding. And make sure that you are working or creating a client that orchestrates in the way that you wanted to do this. And in here we go back to what we can now call the basics of working with AIs, which is knowing exactly how to talk with it, how to ask what we want, how to use the right kind of prompts, and so on. So yeah, that is pretty much what I wanted to share, that we can use, at least we can use and play with these kind of tools without making a big fuss about it, and actually have them bring value one way or another in our systems, and yeah, have them evolve naturally in our product. So yeah, let's talk if you want. Thank you.
Thank you, Mihaela. No questions for now, from what I see. But if there's somebody, eager to ask something, shoot a question on YouTube or LinkedIn, and we'll be sure to answer.
Yep. Thank you, and sorry it took me a bit.
Thanks again. It's been a really good segue to what I'm about to present, to be honest, because I will totally show people how to and recommend using tools and not MCP in their own agents. It's going to be really funny, guys.
Let's see.
Right. So let me share the screen somehow. I'm going to share the screen, the right screen, meaning this guy, and hit share, and suddenly things will not work anymore. Apologies. Right. And just a moment. Can you see I'm not doing this whole day? You can. Awesome. Right. So we'll be talking about MCP versus tools for autonomous agents. I'm going to make this quick, right? So what's an agent? Well, I'm going to quote shamelessly of Chip Huian, saying that an agent is basically anything that can perceive its environment and act upon it, right? And here's a hint. It's going to need tools or MCP to do that, but it's going to need a way to interact with this environment, because by default an LLM can just spit out text, images, or sound, but not click on machines. So what environment can it affect, and how can it affect this environment, right? So then we get to the concept of tools, right? What are these actions? What's a tool? Yeah, this is how you get an agent to perceive this environment, and this is how you get an agent to act upon it, like you've seen in Mihaela's presentation, right? But I'm gonna take things a bit more, philosophical in this regard, and just ignore some some other things, right? What's a tool? Well, I'm gonna show you the exact way to define a tool in using an OpenAI LM and OpenAI API, and then I'll show you how not to do that, and how to basically get away with the simplest thing that works. But what's a tool? Well, for example, a tool can be a way to help a model get the current weather, right? Or help the model, give it a calculator tool, or help the model generate an image. I'm going to show this, by the way. So how do you do it, right? Well, you, depending on the API, but in essence, you tell the model, okay, look, you have these capabilities, like get weather, generate image, edit image, check my email, delete everything, forward everything to my boss, stuff like that, right? Functions. And you make them available to the model with some descriptions. Okay, this function, this get weather function, right? This is used to get so I cannot select. Interesting. I'm using a very fancy presenter tool, but it's not that fancy, right? So get current temperature for a given location, right? It gets it receives an argument. That's the location, right? It's a string, like Bogota, Colombia, or Bucharest, Romania, something like that, right? And then you just carry on using the classic API, the classic, in this case, classic OpenAI API, but you also tell it, okay, this is the tool I want you to call if you feel the need to, right? So we're moving towards an agentic paradigm in which the LLM decides whether or not, as you've seen before, to make a plan, in this case, to call a tool, right? It can decide, and you do the calling. Don't. There's no doubt about it, right? In this response, it might include some text. It might include some snippets asking you to, okay, run this get weather function with this parameter for Bucharest, I don't know, or for Paris. But you will be doing the calling, right? The harness around the LLM does the calling. But that's a sample of a tool. And it's demo time. I wanted to show you how to create the simplest agent with tools, but no MCP. Still no MCP, because some things should be simple. Right. So what do I want to show you? I want to show you a simple way to integrate with a model I really like called Flux Context Pro. This is available in Azure Foundry, in Microsoft. Right now, it's I'm gonna mess up the name so bad because they keep changing them. It's like it's a roller coaster. One thing I know for certain, it will not be called Microsoft Foundry next month because they'll probably change it again, right? But anyways, in this Foundry thing, it's an image generation model or an image editing model. But basically, here I asked it to draw Dr. Seuss, and well, here I have the wow, I knew the name, the top hat cat, right? Easy. That's in a UI. I don't want to visit the UI. I want to write some code that uses this, right? So of course, I wrote some code that uses this, some 163 lines in Python, right? But in essence, I have some, let's say, some setting reading, some helper functions to check if paths are good. We'll see why in a moment, and some functions that basically connect to Microsoft Foundry. And based on a prompt and on a file name, they generate an image and save it right there. That's one for generating the image, and another function to edit an image, because Flux can also edit images. It's pretty cool, right? And it's way faster than OpenAI's image generation model. Right, I have this code. What the hell do I do with it, right? Well, for starters, I can just use it as it is. Right, so I'm gonna generate a snow globe with a cute cabin, right? Save it, retrieve the path, and then try to edit it to change the cabin to a Minotaur. And yesterday this was working. Right now it's being throttled because of violence. Yes, because an axe body spray. Kids, you're not allowed to see that. But let's see. Let's see. So I'm running this. It should take a few seconds to generate a rather cool, rather snappy snow globe. There I am. I have it here. And it's content rejected due to violence detection in prompt, which is great. Which is great. By the way, so there's in Microsoft Foundry, there's some filters that you can set. I set this to the most permissive things. I cannot render an axe body spray. Yes. But that's beside the point, right? My point is, in order to generate something, I need to write the code that generates the thing, right? But I don't want to. I need to think of the best prompt. Maybe it would be better if this language would be more flowery, like an intricate with a cute and utterly cute and all this crap that LLMs love. Push a bunch of attributes in there and hope for the best. So how do I do that? Well, glad you asked. You can do that with an agent. So let me show you a little agent. And I will run this agent with UV run main py. And I'll show you what it does, and then I'll show you what it... why does it not copy? My system is freezing. Never buy a Mac, I guess. All right. So this is a simple agent that asks me, okay, what do you want to generate? Right, and I'll say, what do I say? What do I say? Cute, utterly cute, Christmas scene with dwarves and orcs. Yes, that's what we want. Right. So right now, this is actually an agent hooked to an LLM. In this case, it's I think it's GPT 5.1. And hooked up with some tools, with basically these very tools that I've shown you, right? It can, based on my instructions, right? It can decide whether or not to render something. Let's see what it did. Okay. Oh, this is so cute. This is so cute. Let's add a Minotaur without the Axe body spray in the background. Add Minotaur and a BG, and hopefully it will understand what I mean, right? So now, you know, the LLM again takes the decisions. The LLM initially decided to call my tool to generate and save the image, and right now it's calling a tool edit and save the image, right? It identified that before, so it knows this image I've created. And it used this path to create a new image. So it edited that path. So you see, they're almost the same. It's quite... The Minotaur could use an Axe body spray, but still, right? Agentic. Okay, let's. So you can get all sorts of cool stuff. Believe me, it's quite addictive, right? They could look tougher. Right, so how does this look like? Well, you'll be amazed. It's 98 lines of code to write an agent, right? This day and age, and some of it could be some of it it's comments, right? So how does this look like? For starters, I just took this code, right? The edit and save image function. So code I had written that accesses APIs, that handles authentication, right? And that before I had used, deterministically, programmatically, and now I'm just decorating them as tools with an attribute I'll get to in a moment, right? Telling the LLM, as you've seen in Mihaela's talk, just like with an MCP server, right? Telling the LLM, okay, this generates an image based on the specified prompt, blah, 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 blah. It gets these arguments, and then it just forwards the logic, the prompt, and the output to the main code. Same for the edit. And in case you want to edit an image that's been previously saved, get all editable image paths. Now, I'm making some checks over here, just a parenthesis, because I don't really trust LLMs that much. But I am making sure that this output path is only accessible in a root path. So any attempt to get out of this root path is blocked, right? I'm not allowing the LLM to read or write to another folder than my trusty, I think it's project/images, right? But because I'm handling this. But other than this, it's just forwarding after forwarding. And then it's of course the OpenAI client. Here I'm using a library I wrote. It's called ZipCoil, by the way. Basically, this the purpose of this library is to simplify, defining these tools, right? So before, you've seen in my slide, this was the code needed just to define a function called getWeather, right? With this, you just define the code and decorate it with this tool decorator. Yeah, I didn't find any comparable tool that also maintained the OpenAI API, but added this on top, so I kind of wrote it myself. quite enjoy it, right? So with this tool, and you could use either with Zipcoil or by integrating with the OpenAI API directly, but you can define something like an agent that is aware of the tools we have. Set a system prompt, as you've seen, setting the context, and then it's just a for loop, right? If you press Q, it ends. Other than that, you run the loop, ask the user to tell you something, and it's a bubble. Okay, so these are tools, right? What's actually? Let's see the next slides, because there's a story. But one question you might ask: okay, why do I want to use MCP when you can use this, right? And I have a good answer, I think. Right, good. about this MCP thing, right? So you've heard about MCP. It's been introduced for like a year by Anthropic. It's really taking off, even though if you look at what coding agents are doing, like Codex and Claude, they're kind of phasing out MCP and in the favor of skills, because you can get into a situation in which you get so many functions, so many MCP servers added like crazy, and you get into a situation that the model is unable to, or it gets confused when picking the right tool, right function, right? And that's something to worry about, right? So what do you use? Well, the way I see it, MCP is a plugin system, right? It's a plugin system for agents, right? You want to add some behavior, right? Draw images, I don't know, email your boss, whatever, format the hard drive, why not, right? Anything. And you want to add this capability to an agent. But if you're writing the agent, to my eyes, it doesn't make sense to use MCP. But if somebody else is writing the agent, right, Claude desktop or ChatGPT desktop or anything else, then it makes sense. It makes sense because you're not going to change their code, right? So then I sincerely recommend using tools for the agents you build, and MCP for the agents that other people build. Because that's to my eyes, that's where the value is. All right. So let's do this. You kind of saw this in what Mihaela was doing, creating an MCP server, but this is a bit different. So let me start off my fancy server that I have not started, so it's clear. And I would start. I should have some shortcuts. Why do I have conflicts? I do not know. But I'm going to run the MCP server, and it's going to run locally. You see, it won't be invoked by the client. And then I'm going to add it to VS Code. But before I do that, you see, here I'm using Claude. And I'm going to ask, what tools do you have available? Have you tried this? I'm just asking it, okay, what can you do? Right, and until it answers, I'm going to add an MCP server. It's not going to be a command, right? Because I want to start it myself. I don't want VS Code to start it for me. And then it's this. It's make it so from Star Trek. Right, so I have it here. All right, so man, has it got some tools, right? It's it knows about Docker containers, even though I'd never use it for Docker. So that's eating context and confusing the model at every step. It's great. So it's running. What about now? Let's see if it knows something about images. Same. I guess I'm gonna have a draw image of an owl, the best owl. Yes, I would like. Awesome. So now it knows about I had to start a new thread. It knows about the MCP server. I'm just going to allow everything in this session. Yes, all the tools. Right, which is a bit unsafe, but I made them. So if they crash and burn, it's going to be my fault. Right, but here again, as in the CLI agent, you can see based on my description, right, the best owl, but it generated an entirely expanded sentence, and you can prompt this, right? In my case, I just prompted this to be optimized for Flux Context Pro, but I could have, in theory, just copy pasted everything from their prompting guidelines, so the LM was aware of them. And it's that's not the most magnificent owl, but it's an LLM. What does it know? Right, but in essence, we have a server giving GitHub Copilot, which is not something I wrote, the same capabilities that my agent that I developed myself had, right? And I did this with basically the same thing, right? So the only difference between zip coils decorators and here it's the MCP at MCP tool, right? Other than that, I even get the prompt that this is copy pasted because I wanted to use the same thing, right? So I'm using fast MCP. It's really easy to write a server, not as easy to write a client. And that's a hint. Don't do it. But really easy to write a server. All I had to do was define two endpoints, forward them to the library code, make sure they're prompted, because all these prompts get into the context, right? So describe your image tools. Right, so it quotes ad literam from what I've sent it, right? It knows these things. And that's all it takes to create an MCP server. It's crazy. It's crazy easy, right? So if you want to extend, somebody else's code, I'd say this is the way to go. If you don't, I'd say invest in in tools. Before I end, because my time's running out, one thing to remember about MCP. The S in MCP stands for security. There's this running joke, but yes, I think Simon Willison, who's a great blogger, I recommend you follow him now, has been repeatedly writing and talking about the lethal combo of things you should not do with an MCP server. Don't give it access to private data while it has the ability to communicate externally, while it has exposure to untrusted content, right? So don't do it all. If it has access to private data, then don't give it the ability to communicate externally. If it's exposed to untrusted content, because somebody else could prompt it and it will leak this private data, right, through an URL. If it can communicate externally, either give it access to private data, or if private data doesn't exist, then you can expose it to untrusted content, but make sure it cannot leak anything, right? But really pay attention to how you design your systems around this, right? How you design your MCP tools. And that's in the end, and one fear of mine is that in the end this burden gets pushed to the user, because one MCP vendor will write something that has access to private data. Another will write a server that can be exposed to untrusted content. See GitHub, and GitHub issues reader, and another an ability to externally communicate. And then you, the end user who did not know about this, gets in a very interesting situation. All right, that's all I wanted to say for now. I hope it's been interesting. I will put the code on GitHub so you can read it with an MCP server near you. Right. If there are any questions, I saw there were a couple on YouTube. I'll get to answering them. Thanks for watching, and I will see the scene to my friend Andrei. Hi, Andrei.
Hello, Vlad. Can you hear me, right?
Loud and clear.
Oh, perfect. Oh, perfect. Thank you very much for inviting me here. I follow both your presentation, yours and Mihaela's, and they were pretty interesting.
Thank you.
We are three people that are talking about MCP tools, and each of us is speaking differently about MCP tools. That's great.
Yeah, it's a new. I think we're all learning in the end.
Yeah, that's right. So
I will fade away and let you take the spotlight.
Thank you very much. I will share my screen. And this is the content of my presentation. So we speak very fast about AI LLM, then about MCP, then about Visual Studio and MCP, then how we construct an MCP server in .NET. Both Mihaela and Vlad show you how to construct an MCP server in Python. I have lived in .NET, so I show you how to construct an MCP server in .NET, how to deploy on NuGet in order for others to use your MCP, and then something very short about MCP versus OpenAPI, and question. Let's see that the time allows me. But first, something about me. This is my blog, the first one. I keep talking about .NET tools, and I'm having fun sometimes with a book of copy-paste from Stack Overflow. How do you copy-paste from Stack Overflow? I may put on date to know how to copy-paste for LLM, but that's another story. And I'm now very fond about roasting source code generators with examples. So if you know .NET, check it out. Now, the first slide, it's about AI LLM. What I'm using, it's Ollama. Here you see Ollama on the internet. It is a desktop application, a command line application first, that you can download models. So you can download Phi3. You could download, let's see, DeepSeek if you want. You see here DeepSeek and many other models. How we use it? If you know Docker, it's rather the same. So we say Ollama ls, and we see the models that we have here on my PC. And I can run Ollama. Let's see, let's run Qwen. Ollama run Qwen 3. And now I have LLM that it's on my PC. I have downloaded like Docker images. And now I can ask him something. And what I want to ask him is when Napoleon was born. And he is thinking about how Napoleon is born, and this is how he thinks. And sometime later, he says to me that he was born in this date. And let's say that they are pretty sure that it's this date. And then I ask something simple. Then what is today's date? And now he's thinking about today's date, but he doesn't know he was made Qwen 3. He was made in April 5, 2024, and he thinks that today's date is April 5, 2024. And this is how you understand that the models have their limitation. So as you see, he doesn't know the today's date. So I /exit, and now I want to provide a model with some capabilities like the today's date, or you can think about other capabilities, understanding a database that was not created this time, or understanding something else. And for this, I have a simple code here. I have something like, let me do an explorer first. Okay, it could be code, Visual Studio Code. And just a moment, because it doesn't want to go there again. Sometimes the presentation gods are not with me. Just a moment. Okay, so in this folder, I have something that is MCP host. The MCP host just talk with the Olama, and it gives him the MCP that we have. So in this case, I have an MCP server here that shows the time that it's running on my machine with Docker. You see Docker run MCP time. So what is doing this MCP host, sorry for this, that it's again, it's not my invention, it's all you'll find on the internet, that it runs this Olama Qven3, but now it runs with a config. And this config local JSON starts the Docker with runtime, and now Olama will have the AI, the Qven3 will have a tool that could show the time. So see, you hear that you have loaded two tools for MCP server here, and now I can say, let's put it the same question, what is the today's date? And now it should call the time zone, and you see now that the date is correct. He is executing time current time from the MCP tool, and it says correctly that this time is December 16. Okay, I interrupt again. What I have done is just I have plugged in this Docker run with MCP time into the Olama, and now he knows the current time. Okay, now the general presentation from MCP is like this. How I can, if I put a question, a simple question to the AI, how can he answer? So the question is, how can I go to ski? If I can go to ski to Brasov, and how I get there? So there are two questions here. One, if the weather is correct for ski in Brasov, and the second is how I can get there by train, for example. And that means that the LLM, the AI, however you say, should be adored with a get weather MCP tool, and with the train railway that that can show him what are the trains with each hour and so on. So how an LLM can think. So he has a get weather, he has a get location, and he has a get trains. 3 MCPs, like we have registered the get time before. So LLM is analyzing the question, understand the Brasov is a city, calls get weather with the Brasov city, then the answer goes back to LLM. The weather, he can understand that he can ski at -10, then he gets the location that is Bucharest, and then he gets the train between Bucharest and Brasov. All this kind of stuff, it's going forth and backwards from the LLM to MCP tools with the information. So all the information, it's enriching the context of the LLM with the information from the MCP tools. So if you have 10 or 20 or 100 MCP tools that you are calling, the context will get bigger and bigger and bigger. This can be a problem or not, depending on the tokens that LLMs can support. Okay, next. What are some examples from MCP? The first examples, there are the example servers that are coming from Claude, that is the creator. And you see here that it's file system. If you want to give access to the file system to your PC to some points, it's sequential thinking. It's time that I have shown to you already the MCP time. And here it's with Docker. Here it's showing how to install in Visual Studio Code Docker. And more MCPs. Stop. You can find here on GitHub on MCP and Microsoft MCP Server, Azure MCP, Microsoft Fabric MCP, Microsoft Foundry MCP, Azure DevOps MCP, Azure Kubernetes MCP, GitHub MCP, and so on. Mark it down MCP, more MCPs as you want. And what it's very interesting is that NuGet, that previously was something that you put shared DLLs there in order to share things, and here MCP server. And if I click apply, there are 65 packages already on the MCP deployed on the NuGet as MCP server that you can download. I will show you later how to download those. Okay, next, Visual Studio. You can add MCP servers in order to use with Copilot. Okay, now let's see the presentation. Code, and I put it there. Okay. How do you put in Visual Studio Code? Either you click on here on Visual Studio Code and ask him, or you can create on your folder that you open with MCP, this MCP JSON that it's there are commands with servers, and you put all the servers here. The MCP comes in two flavors, as standard input-output and HTTP. And let's see this Docker. If I start run, it says running, and this was the Docker that I showed you before with MCP time. The file system that is from Claude. This is one of my MCPs. What I want to show you is something that it's an MCP that I try to start and see what's happening. Just a moment, I want to put here. So this MCP has fetch with command UVX and with args MCP server fetch with type as standard input-output. And I want to start it. And when I started, you see here, starting server, connection state starting, connection state, arrow spawn with X and end. And this is because the MCP on my, I do not have on the local computer Python. If I do not have Python, I do not have either UVX. So in order to run the MCP on the local host, you should have the command arguments that you need. I can start this Docker because I have Docker. On the other hand, the MCP on HTTP, you can start, and it just wanted you to authenticate, but this is not the idea. The idea is that can I start any MCP that is deployed on HTTP anywhere? So there are two kinds of MCP, one that it's running on your PC, and one that it's running on other computer. On the HTTP, sorry. Okay. Now, how can you see these MCPs? So, let's say that I'm running the MCP. This is an MCP that I have done, MCP array to any. And I have an MCP array to any on HTTP. I will start an application that I have MCP. We'll go back to this. And I will start the application, and it's running on the port 5000 here, localhost 5000. And on the MCP JSON, I will run this MCP on port 5000. I can start it. And now I can say to the agent, I have here, I will take the model Olama from Qwen3 from Olama. And I can see now the MCPs that are loaded. And for this one, I have MCP array to any from HTTP, I will click on other things to not be run. Okay. And now I can say, just a moment, please transform to CSV the following. And just a moment, let's say that I want to transfer to CSV the following, this one. And I run it, and hopefully he will call my tool and transfer to CSV the JSON that I have shown to you. It's optimizing the tool selection. We wait some time, not so long. It's working. And you see that he wants to call my MCP here. And I say allow and run convert array to CSV. And after this, he will show me the data. He doesn't show me that, but let's see. Okay, it's an error. Okay, happens. That they didn't call with the right arguments. I do not want to stay here. I just want you to show how you can see what you have created on MCP or any other MCPs. Okay, so what is provided by Claude, it's provided a tool that works if you have installed NPM on your system, that it's called Model Context Protocol Inspector. And with this inspector, I can connect to the MCPs. There are two types of MCPs here. SSE, it's basically again an HTTP. It's standard input-output that you say the command, or HTTP, and I have this localhost 5000, and I say connect, list tools, and you see here the tools, convert array to CSV, and I try to put the same array, and I said run tool, and this time has worked, and he put some CSV here. I have also convert array to markdown. Let's put here list tools. Okay, convert array to markdown. I put the same array, run tool, and you will see the same array here, that it's a markdown data. So from MCP to see the MCP that you have created, you have this Model Context Protocol Inspector that you run with npx. npx is like npm run, and he downloads on your PC this one, and you can try any kind of MCP with this inspector. Okay. How we construct an MCP server? I will show you, like Vlad has shown to you, a simple MCP server in .NET. I will close this MCP array that it's running, stop it, and I go, just a moment, on the presentations, on the code. Okay. Okay, this is a simple MCP tool that uses two packages. That it uses the Model Context Protocol ASP.NET Core, and it uses the Model Context Protocol behind. The program is very simple. It's a website because I want to create HTTP. It's very short, and it has the application Create Builder. You can add an MCP server with HTTP transport with tools from assembly. That means that tools from the current things. And you say also map MCP. So add the MCP server and map MCP. And you can put it to run on a specific port. I have put here 3001. And what you say, it's create a class with a function that says, for me, I have created something that converts a message to a string 64. So let's run this one and see with MCP inspector. So I said that it's on localhost 3001. Just a moment. I want to copy this one. Okay. So it has started. I am going to MCP inspector and I put this port. I say reconnect. Okay, let's go refresh and say connect. So on connect, I'm listing the tools, make the message base 64 that was here, make the message base 64, and you see the description, encrypt the message from client is here. So I said here Gen AI Club, run tool, and it gives me back the name. Also, I can connect to this server tool if I put in the MCP JSON instead of localhost 5000, 3001, and I can use this MCP host. Okay, this was the demo how you construct an MCP in .NET. Now, how do you deploy this MCP in order for others to have something? Let me see the presentation. So I have this package, MCP array to any, that I have deployed. What it does, it converts any kind of JSON or TUN string to HTML, Word, Excel, PDF, and so on. And here it can show you how you can put in Visual Studio Code. So MCP array to any, type stdio with DNX. You see here DNX. You should have DNX on the system, like .NET executor, like you have UVX, that is the Python executor, and so on, or Docker or something else. And it shows you how to put this. How do you deploy this? It's clicking on upload and deploy MCP array to any. The strange part is that you do not deploy just one executable. You deploy multiple executable. So if you want for others to have your MCP at standard input-output, like here, running on their machine, think that their machine could be Windows, could be Mac, could be Linux. So what we have to deploy there is not just one, but more than one. Let me show you. We have MCP array to any here. And if I click here, we have MCP array to any Win64 that is here. And we have also MCP to any Linux x64. So we have many things that we have to deploy. Let me show you how you generate those packages. And the deployment could be done very simple with a GitHub CLI action. With a CLI, you can do this very, very easy. Just a moment. Tools, CMD, CLS, and I say .NET pack, and I pack in a folder upside, and now it creates the package that will be deployed to NuGet, and you see here that it creates Linux, OS X, and so on. And in some time, I'll go to Explorer now. And in Explorer, just a moment, Explorer dot, and I go up one folder, and I go to here, and you see here MCP to array to any. Okay, just a moment, I will delete again to clear and make the pack again, and you'll see here appearing the MCP array to any, and you see that are new packages that are prefixed with Linux, Windows, and so on. That means that when DNX will install on your system the MCP array to any, he will install depending on your system. He will go and grab the Linux if you are on Linux. He will go and grab the Windows if you are on Windows, and so on and so forth. So the idea is that when you construct an MCP, you have two things. You have a standard input-output, or DNX. The MCP array to any for me, because I put an argument here, HTTP true, I can start it either in HTTP, either as DNX. And you see here that if it's standard input-output, it's with standard input-output server transport, if not with HTTP transport. But otherwise, the code means that it will be somewhat the same. Good. I do not have much time. The last question, MCP versus OpenAPI. Generate MCP from Swagger or Swagger for MCP? So this is the primary question that I see. You generate function from someone that uses MCP to use your functionalities, and also generate for programmer Swagger. As a programmer, I know better Swagger than MCP for now. So the question is, what do you use? Let me show you the MCP array to any, that you see that it was downloaded with standard input-output. Now, if I press F5, I can run HTTP. And I'm going to Swagger. And you will see here that the convert array to HTML, Markdown, and so on are generated. And believe me, they are generated automatic from MCP. Why? Think about Swagger. Swagger is more dedicated to programmers. I'm trying to find the presentation here. Swagger is dedicated to programmers. So if I made to Swagger transforming array to any, I have said transform JSON array to any, transform to Word, let's say, transform CSV array to Word, transform, and so on and so forth. So Swagger, for me, being dedicated to programmers, it's more granular, more fine. You, as a programmer, I know what Swagger I want to call because I know my data. For MCP, you do not know your data very well. So the AI can choose to call your MCP. So your MCP must be more generic. And so if you have all the Swagger functions that are very granular transferred in MCP, that will be a pain in the ass for the AI to choose between your Swagger function transferred in MCP. But the vice versa is not so not so hard. You can transfer any MCP function to a Swagger endpoint, and then you can refine. So for example, here I have the function convert array to HTML, and I can say convert JSON array to HTML. I can add other function that transfer just the JSON array or the CSV array or something to make it faster for the programmer that knows how to call this by Swagger. In short, because MCP is dedicated to humans and AI, not to programmers, it is not so fine-grained like Swagger, that is dedicated to programmers that knows what to call, when to call, with which data to call, and it's their fault, the programmer's fault, if the Swagger doesn't answer very good, because they didn't give them data as they should. Okay, this was the thing with MCP. I do not want to show you now the Swagger, but believe me, it works with this Tune MCP. And I have been coming to question if you have question for me. Someone asked here about security. Sorry, Vlad.
No, that's what if you can add to that question.
Okay, for me, the security is how Vlad says. How do you secure your REST API Swagger? The same thing you should allow to secure your MCP. Let me show you again the MCP here that I have in MCP JSON. You see here the GitHub MCP that when I said run, he want to authenticate me via OAuth. This is the protocol, and you should follow this protocol because it's well documented and it's okay. Otherwise, it's very hard because MCP doesn't know how to make a Windows authentication. Sorry, AI doesn't know how to make Windows authentication or others. More than this, I want to show you about security. I have installed on my computer MCP tools, but I have here, and I promise I finish, the first malicious MCP in the wild that is stealing your emails. That means that if you install MCP and you do not access via HTTP, cancel, I do not want now to show this, and you install on your computer and you run all kinds of MCP, be sure that it's from producers. For, let's say that you want to install a MCP for a database, to not install from Hacker99 around, I do not know. Just go to, if it's a SQL server, go to Microsoft and see what MCP server, SQL server has Microsoft. Or I do not know, for Postgres, the producer of Postgres, and so on. Otherwise, yes, I am agree with Vlad about the S in MCPs for security. Yeah. Okay, I think that this was all. Thank you, Vlad, for having me, and Gen AI Club for having me.
For all the details, I was wondering, you're not, just a bit biased towards the Python side of things, and it's great to see, yeah, also an alternative point of view. So many thanks. Next off, as I mentioned, last but not least, we have Daniel telling us more about what can be done after I click the right buttons with MCP and Microsoft's agent framework.
Yes, I'm here. Can you hear me, Vlad?
Yes, absolutely. Hello.
Hello, everyone. The lights are not good here, but I'm sure people are here for something else, right? So I will share my screen in a bit.
I will be fading away.
Okay, can you see my screen?
Yeah, it's visible.
Good. So I will continue the talk about MCP, but this time from the Microsoft Agent Framework perspective, which is orchestration framework from Microsoft, a very new one, but I will discuss about it in a bit. I'm Microsoft MVP on AI and .NET, and I'm writing a book about, of course, Microsoft Agent Framework. I started the book for semantic kernel, but semantic kernel was put in maintenance, and Microsoft unified this framework with AutoGen and created a brand new product called Microsoft Agent Framework. Semantic kernel was very good for enterprise products. AutoGen was very good for research products. And now the power of the two emerged in one unified product, bringing the best from both, hopefully. The key features, in addition to the fact that it's unified, it's now it's enterprise ready, and it unifies more concepts or pillars like Open API, MCP. We'll discuss about this in a bit. Agent-to-agent protocol. I can add more. It's Agent UI, another new protocol. So it seems like the support for cloud, for services, for Anthropic, for example, it's extending continuously, and we can expect to see more and more interesting and nice features. And in this moment, I have the feeling I'm losing control in a way that I don't know what to put in the book to be relevant, still to not go too far from the original goal. But indeed, as a product, it's wonderful to have everything under the same umbrella and to be able to build a variety of applications. Now, I will touch the on-premise part of the application. Of course, the models can be in the cloud, like OpenAI models, or locally, like Olama served models. But this is not the point. The point is how we can build an MCP server and consume it from development perspective. My colleagues presented more scenarios. So I will focus a little bit on hands-on building everything from scratch alone. This can be very useful if we try to build a product which has not so many dependencies, but everything in one place. And probably sometimes a product which does not leave the local network, which for some organizations is a must. Let's discuss a little bit about what are AI agents. I think I cannot emphasize enough on why this is important, but let's see what are the ingredients, the key ingredients of an AI agent. So an AI agent has a built-in chat client, and it uses this chat client to connect to generative AI models. In addition, it has instructions, because the instructions define the persona of the agent, and it has tool calls. But let me show you a little bit why are these parts important? Because these 3-4 parts make an agent. So if you want to have an authentic agent, not a simple chatbot, then you have to have the reasoning part. You have to have the memories to deal with the memories. Yeah, you want your agent to remember. And you have the actions. So the actions are very important, and this is the difference between a chatbot and an agent, because via actions we can act in the real world to trigger some actions. These actions can be read or write. Retrievals, if we read some data from some databases or files or whatever, to bring in more context or processing data. And then we have the right part, which is taking actions. I mean, we can trigger. If we have a car, we can move the car. If we want to write some data or to produce some results, we can, again, write them, persist them, or simply call an API. let me take you to the deeper to the tools layer. Tools layer works with, of course, with tools, but we may have the built-in tools, which we assemble in our application, or we may have third-party tools, which are provided by third-party actors like Microsoft or GitHub or whatever. So we need both, because we don't want to reinvent the wheel. Then we will use third party, but in any moment we may have some our tools which we want to quickly assemble, but we can create our own server. And this is what we will discuss in this talk. Now this is all together. So again, the agent, and then the tools, either built-in tools, either third-party tools, or our own. So the MCP addresses some problems. The standardization of the tools. We don't have to build again and again the same kind of tools. Probably somebody else did it already, and then they can assemble in an MCP server somewhere, and we can consume. And then of course, we want to avoid the duplication. Well, the MCP, an MCP server does not host only tools. It hosts two more different kind of entities, and these are prompts and resources. So a prompt, well, a tool, let's start with the tool. A tool is traditional code, is some logic we want to code and to keep it in an MCP. But prompt is exactly what we send to ChatGPT, but it can be parameterized. So it's a reusable prompt, probably with moving parts, so it's dynamic, not necessarily static. And then it's resources, which can be a URL to an API where we can call some data, can be a database or physical files. But these resources are very important for the context. When we try to create good queries, it's important to have good context. So sometimes we have to read this context from some modules, and these can be MCP as well. Resources, it's such kind of piece which we can use to bring more context in our application. And then it's important to discuss about the transport types. Well, we have basically two big different ways. One is to keep our MCP. Now we discuss about any kind of MCP, but it can be our own. And then we build it and we want to quickly consume it. And then we can run it in process. And this is the easiest. So standard input output, or STDIO, is running the MCP in process. And then it's having this MCP over internet or over some communication channel. HTTP, it's the well-known standard for this, but again, we can have HTTP in two flavors. One is stateless, the other one is stateful. Stateful works with server-side events, and this is the default mode. And stream mode, it's actually not a standard communication channel provided by MCP protocol, but it's standard implemented in agent framework, and it helps us to build a communication between our dependencies via name pipes or sockets, or simply in memory streams. So it's very important if we already have these communication channels and we want to build on top of them. And as I said, probably it's not HTTP. So having stream, it helps us to cover this scenario. And pretty much we cover it all potential scenarios. When we build our own MCP server, we get some traditional code, a C# class, for example, because I will exemplify in C#. And we annotate the classes with some dedicated attributes. I will show you in a bit in the code. But then we want to consume. When we consume, again, we define the transport type, initialize a client, and discover the tools provided by the MCP server, which we implemented in the previous slide here, right? Let's see. This is summarization about the transport types. So again, standard input-output. It's for development mode. So we build this in development, but it's not recommended for production. For production, go with the other two, HTTP or with stream. When to choose MCP over AI tools? Because the AI tools, it's having these tools built by us. MCP, as I said before, it's a standardization. So when to get our tools outside our application and put them in an MCP server? Well, of course, when we want to reuse among multiple applications, or why not when we want to give it to the world, like we can find a lot, and our colleagues already discussed about a few, like GitHub. So yeah, it's for standardization and usability, and write once, use anytime you want. Yeah. And let's see the code. Okay, first let's see how I build. I will get you through the code a little bit, presenting the parts. So first, I built an MCP server with standard input-output. This will run in memory, right? So it's not for production again. And the code itself, look, it's it's about 40 lines of code. So it's very compact, very clear. Not to mention then that I added the logging because we want to see what happens there. And then we add here the MCP server to the middleware, and we bring in some already defined tools or prompts or resources as I specified before. Let me show you how they look. For example, tools. I have here a class which has like 5 different tools. So I have annotated the class with MCP server to type attribute, and these will help the server to discover this class as being a tool collection. And then each tool I have annotated with MCP server tool. I put a better name for AI. Look, here we have this C# like naming convention name. It's backward async because the method it's asynchronous, and then I have the Pascal case or this naming convention. But generative AI loves the other convention like snake case convention, and then I took a minute here to put this custom name, which is of course not too different, but it's clean and clear, and I gave it a description. And then I did the same for the other methods, and we have now a tool collection, yeah, a tool set. Now let's go to a prompt class, and here I have a method which returns nothing else but a prompt we plan to send to the generative AI model, to the AI model. The first method, it's very simple because it uses or returns the string type. Here we have a query. We can read this query and send it to the generative AI in our agent framework application, or actually anywhere, because this will be an MCP server, which is just a service, and this is like a black box. It's agnostic. No, we don't know yet which application will consume it. We have to be ready for any. So another way is to return a list of chat messages. Then we can pack this prompt in a chat message, in a user chat message type. Now, the previous one returns string. So the MCP server will do this for you, but sometimes we want to return not one message, but a few, like having a chat history. When you have a chat history, then we can have a mix of user assistant messages. So the user, it's what the user sends to the AI model. Assistant message, it's what the generative AI model responds. So we may have a collection of this, like a chat history, like a chat session, and we can persist this and have this in the MCP. Why not? And then, of course, we can have arguments. And having arguments, it's a very powerful feature, because in this way we can parameterize the prompt. Therefore, we can have a dynamic prompt which reads some states to assemble a prompt, to assemble a response. And then let's go to the third one, which is the motor resource. Here, what we have here, just plain text. But we could have some information from a database or from another API. But for simplicity, what I have here, it's only some context. Here, pretty much static text. But as I said, it can be dynamic to read some real-time data from service, from database. And having all these three type of MCP entities, we covered it all, and look how easy it is to start an MCP server. Of course, we can run this, but we will not see much because it's just exposing some data. But worry not. In order to, we can use a tool which is like a user interface which discovers what our MCP server exposes, and it shows in a user-friendly way what the server exposes. So let's start this. This will trigger a new page here, and let me connect. So I click connect, and I'm waiting now. And look, it just got populated. So we have here a menu with resources, with prompts, and with tools. We have the ping. Let's ping the server. What we have here? Look, the ping says okay. Then let's go to the tools. Let's list the available tools. Remember, we have there 5 different tools, which exemplifies some basic motor comments like going forward, backwards, turn left, turn right, and stop. Look, here they are. I can call the stop tool. Let's run this. And look, it says stopped. And let's run another one, backward, for example. And I will put here, because this has an attribute, I'll put 99. Let's call this. The response is, oh, moved backward for 99 meters. So obviously, it's a way to explore what our MVP. And then we have the prompts. Let's see, parameterize message prompt. Let's define here an action. Let's see, go round. And then this will get wrapped in exactly what this method does, and it will return a prompt. And the same, have here this resource. We can just read this. Okay, good. So what we have so far, it's the MCP server, which we just built with any kind of resource available potentially here. And then this will work nicely for development. But if we want to have such thing for production, we will use HTTP protocol, but not before showing you the client. So again, we have the MCP server with a standard input-output, and then we can consume it now. So let's run it. But look, we don't have to start the server ourselves. All we have to do is to define the standard input-output transport, which tells how to launch our application. And look what it does. It calls the .NET runtime executor. It runs it with this project with no build attribute, because we don't want to rebuild every time. So as soon as we have this transport type, we can instantiate an MCP client. And then, yeah, let's go up to this point where we define the standard input-output transport and an MCP client, and we interrogate the available tools. I will move all in half window here. Let's run it. And let me put in the other half. Come on, I missed it. So look, tools available. So we successfully read what the MCP server exposes. Then let's go to the other breakpoint, which is the reading the prompts. Yeah, so we have 3 kind of prompts. Then let's go here. Yeah, now we see we have a resource here. But so far we didn't yet consumed. We just interrogated what is available. We discovered what is available. Now let's call a tool to see what it does. Again, this is just for understanding how it works. And indeed, look, it responds correctly. Then we did some prompts. Again, they are called correctly. So in the previous part, we listed what is available, but here we try them. And the same, or a resource. And finally we reach to the agent. Now the agent will get populated with some AI tools from our MCP server. And I'm populating with all of them, but we can choose which one we like, but I populated with all of them, all 5. And let's see what happens. So I instantiated the agent. I'm reading the query from again from MCP, because I have the prompt there, and I passed in a command. The command is, there is a tree directly in front of the car. Avoid it and return to the original path. Let's see what the agent does, considering that it knows to do only basic movements like turning left or right, or going forward or backwards or stopping. So let's see. Now it's calling the AI. Okay, so because I asked the agent to avoid the tree, it turns left, advances a little bit, then it turns right, advances a little bit, turns right again, advance a little bit, and then turning left. Yeah, right? It's just avoiding the tree. It's like evading the tree. So this is how my agent was able to use some capabilities, which are our MCP tools, define it in another place, which in our case, it's another project using standard input-output. But as I said before, this is not advised for production. So the question is, can we do this using HTTP protocol? And of course, the answer is yes, but let me show you how. And what we have here, another project which does pretty much the same thing, but this time, instead of setting the protocol with the standard input-output, I'm setting it with HTTP transport, and I'm using stateless equal true. This is default. And yeah, calling the other resources. Let me run this, because now we can see nicely what happens, because we have logging. Where is it? Not this one. Okay, so I will run this application from outside. Why? Because I will use Visual Studio to run the client, and I will run from outside the server, so we can see them side by side. Of course, we can do this in a more elegant way, but now it's about what's easier to exemplify. So look, we have here the MCP server, which uses HTTP transport type and is listening these URLs. And let's run the client, which again uses HTTP, but let's take a look at how it looks. And look, so we have here the client, which again initializes a transport type with the right IP. Yeah, we have it here. Let me show again side by side. Yeah, the IP is here, so I'm using it here. Then I'm initializing the client. Yeah, again, we can check what is available or not. And we can play again to try first the available tools and prompts and resources. But where we want to get, it's to the agent. So let me run this. In the meantime, let's check the right side of the screen. And look, see, the MCP server senses the requests and responds with the right answers. And we reach to the agent. So far, we just interrogated the MCP server and we played to see how it will respond. But now, what we do, we equip an agent with instructions, and we expect the agent to identify which tools are good to avoid the tree. And we do this but by assigning the tools to the agent here. Okay, and let's let it flow. Let's let it flow and see the response here. See, it's calling multiple times. Look, even these logs are from inside the tools. So we have a traceability. We have the traceability here. We can see what happens. Of course, we have more advanced way to implement observability using probably Aspire dashboard or OpenTelemetry. Agent framework is enterprise ready and it has all these features built in. But even the logs can capture what we do. So the agent responds again with an evasive maneuver, and just in case, let's run it again. Let's run it again. And now we expect a similar response, but not identical, right? Because it's come on, pretty identical.
Daniel, one question. I think we're a bit above the timing.
I think we just finished. Yeah. Now, definitely. Okay. Now we just finished. And if there are some questions, I'm here to listen to them.
I think on YouTube, no questions. But I wanted to ask you about so you have looked at the semantic kernel, you have looked at Autogen, now it's agent framework. How do you feel about this evolution?
How I see this evolution?
Yes, of Microsoft agentic frameworks.
Yeah. Well, it's very welcome because semantic kernel changed like 3 times the agentic part, the way the agents can collaborate. And it was pretty frustrating. And even the last time, even if they look the same, they don't work the same. For example, in semantic kernel, we have these orchestration patterns like a group chat where 2 agents can debate. Then we have a sequence of agents or agents working concurrently or using a handoff architecture, which is pretty much like a state machine where an agent can communicate with the precise other agents. And then this was pretty good, but it was not ideal. It didn't work very deterministic. And then agent framework re-implemented this using workflows. And the workflows are like handmade orchestration. So you can orchestrate and you can put exactly this agent or this executor, which may be an agent or maybe traditional code, should go to specific that agent. So it's bringing determinism in the non-determinism. And of course, we still have the agents which are non-deterministic, but at least the planning is not. Because 80% of the times it works very good, then is not. And this is not very nice in production. And the way to mitigate this, it's very complex and it's a lot of token consumptions and budget, right? So their solution was to bring in these workflows which work with the executors which are agnostic. I mean, you may have agents or you may have traditional code, doesn't matter, but you can control the architecture. And for at least for this reason, agent framework is very nice.
Well, sounds you've just made me very interested in knowing way more about this.
Yeah, and you can design your own patterns.
Yeah, I think that's a great feature, because I've been looking at other agentic frameworks and it's like I do not want to handle all control to an LLM that may create a plan. Just as you said, it's non-deterministic. So how does it create the plan? Is it good? Is it bad? I have no idea. So I much prefer having a workflow and handing off certain bits and pieces of the flow to the LLM that it can work as non-deterministically as it deems. But then the overall architecture of the system is still under my control.
Yeah, of course, you can still have a plan built by the AI, but then it's only one agent. And then it's the classic problem of breaking a big problem in smaller, more controllable pieces.
Yeah. What software development is all about, but it's fading away.
Only one idea, and then we can finish. When we work, or when you work with the Agentic AI, with agents, it's a good start if you think of them like microservices, because it's exactly these small pieces which you have the chance to orchestrate. And then you can reduce the chaos as much as possible. And still it's a lot of chaos left.
Yeah. Well, that's why they pay us the money.
Yeah.
For now.
Thank you very much.
Thank you so much, Daniel. Thank you, Andrei, and thank you, Mihaela. Thanks, everyone, for making this a very cool evening. And I learned a lot. I need to review this in detail. And thanks to you, everyone, for joining us. Until next time.
Thank you. Bye-bye.
Thank you. Bye.